Hi students, let's look at this question here, which was actually taken from the year 2019 from the school EJC and paper 2 question 2. This question is on application of differentiation, I believe. So let's see how do we solve this question proficiently. So you're told that in this diagram that it shows a mechanism for converting rotational motion into linear motion. So yeah, this is a linear motion here. This is a rotational motion. So imagine you have a disc here, which is like moving this part, and this will just go in and out. This is I'm not sure whether this is likely to be extendable. So fixed radius r, is that fixed? 2r, is it fixed? Oh, so r and 2r, they are fixed. So these are fixed. Okay, so make sure that you know which are the constants and which are the variable. Okay, so for this case here, this will be fixed, this will be fixed. So what is changing is actually your x lah. So x and obviously theta is also changing. So that is what I have in mind now. So the point Q can only move on the line OX. P and Q are connected by a rod 2R as this rotate. Q is to slide along OX. So imagine that if this were to R is here, then this would be 2R here. This would be X here lah. So x is the variable varying one. So as this move along, this will just go in and out, in and out. So the question now is, state the maximum and minimum value of x lah. So the max would actually be when this is r and this is 2r over here. When this q is here, this is 2r, right? So that will be my max. The mean would be where this is r and this is 2r is equals to r. Okay, so you could the mean will be r. So this is only one mark, so you just state it down. So 1 maximum value of x is in terms of r, right? Is it in terms of r? State the maximum value. They never say in terms of r. Okay, so likely to be in terms of r. So this will be 3r. And minimum value would be 2r minus r. 2r minus r. Okay, so it's like here lah. This is r and this is 2r. It's just r lah. Just state it down. And this is r. Like you don't really need to. There's no calculation work involved. So it's 3r and r. Okay, great. So that's about it. Then the next part is you are asked to find the x value, which is like r cosine theta and given by this. I think this is pretty okay, not too bad. So you're asked to show that part there. So once we are done with this, we are supposed to find the x lah in terms of r. Okay, so I don't think it's really a huge issue. Most likely you're able to solve that already. So I'm just going to show how you could do it. So this part here, I'm going to write a right angle triangle here. So this height here will be r sine theta, right? This height here will be r cos theta. Okay, so that's not too bad lah. So I'm just gonna name this point as f lah. Let part 2 let f be point on OQ be a point on OQ that is closest to P lah. That is to be a foot of perpendicular. So that's okay. So hence PF would be r sine theta. So PF would be r sine theta. Then after that you have got OF as r cos theta. OF r cos theta. Okay, so just use the Tuakaso formula lah. It's not that difficult to see why. Okay, so then once you want to find x, right? You want to find x, so you know that x would essentially be PF plus FQ. OF here plus FQ lah. So that's the reason why I named the foot of perpendicular. So it's not OF, so it's PF and OF. Okay, great. OX is OF plus FQ lah. Okay, So if you're stuck here, don't worry. What you need to do is just make sure you understand this part here. This is likely to be our Pythagoras theorem. Right? This is likely to be a Pythagoras, right? Don't be distracted. So it's okay. So this part here, if you use Pythagoras theorem, you realize that this is actually square root of 2r square minus r sine theta square. Okay? So then there you go. This would be the r square that you're looking for. So by Pythagoras theorem, we have fq equals to goes to 2r square minus 2r square minus r sine theta square. Okay, so this is fq is equals to square root of 4r square minus r square sine theta square. That's where you get your r from. So by substituting in, hence x would just be OF would just be r cos theta plus I'm gonna factorize the r out, because that's what they want me to do. 4 minus sine square theta, and this would be r cosine theta plus 4 minus sine square theta. There you go. So this is not too bad lah. I think this part here is okay. Okay, so shown. What else we need? That's about it. 4x cosine theta plus 4 minus, yeah, great. So this is 2 marks. I don't think you need to write everything out. Pretty much there are pretty few things which are quite okay. I think you don't really need to write most of the things out. Okay, so let's look at the if you have any question, please text me. Okay, I think the first few are quite okay lah. So let's look at the subsequent one, part 3. At a particular instant when theta equals to pi over 2, pi over 6, right? You're told that let me theta dt is also 0.3 radian per second. Is it per second? I'm not sure per unit time is what. So just assume that per unit time. So find the numerical rate at which point Q is moving towards point O at that instant, leaving your answer in terms of R. Numerical at which PQ is moving towards point O. PQ to point O. Okay, so in other words, you asked to find this itself just means that I want to find what's a dx dt lah. Okay, that is dx dt. So that's pretty okay. This question is pretty okay, I think. So you want to find the rate of change of x. That's what they want. They want the which point Q is moving towards O, because Q towards O is just x ma. So you're looking at x value there. So leaving answer in terms of R. Okay, so we need to find dx dt. So we're gonna use chain rule. I think that's pretty okay. So dx dt would just be dx d. Sometimes I'll just ask students to write like that. If you do not know what's the chain rule that is being involved, you just write that. It will help you quite a bit. Basically what you need now is d theta, right? Because this is d theta, right? So d theta dt is given. This is a change. This over here, we know that is 0.3 radian per unit time, and then dx theta could be found by just differentiating this lah. Okay, this looking thing here. Okay, so what I'm going to do is I'm going to find dx dt lah. So dx dt is not that bad. Just use chain rule. So dx dt. So this question, just take note, if you can't do the second part, at least the third part you could just use as the result from the second part to show. Okay, it's not like so differentiate cosine, give you negative sine theta plus half 4 minus sine square theta minus half minus 2 sine theta cosine theta. So this is the value that I get. I'm not sure, but basically I know that theta is pi over 6, so I'm just going to key in calculator. So when when theta equals to pi over 6, dx theta is, just key in calculator, so this is r, just sub inside here, theta value here, and just, anyway they didn't want exact, so I'm just going to key punch into calculator and find my value there. Okay, so let's try. If you have a problem differentiating this, what I did was actually just r cosine theta plus minus sine theta square half lah. So okay, just like that. Then I will get cos theta minus half 4 sine square theta, then differentiate the inside, minus 2 sine square theta, and so on. Yeah, so actually you could use GC and find your dx dt theta if you want to. So this could be, you can use a GC and find it, but I'm just going to key in slowly. So this part here, once you sub in the value, you just is minus sine 30 degrees. So pi over 6 minus sine pi over 6. Pi over 6. They did not want the exact value, so don't need to worry about it. This part here will just be negative 0.723606 r. Okay, so what we want is actually just dx dt. Dx dt will just be dx dt theta, which is negative 0.723606 r times 0.3. So there you go. Because I was able to solve dx dt, this is 0.3. Okay, so maybe this is dx d theta, dx d theta dt. Okay, so I will get that multiply with 0.3, which is actually 0.2. So very good. Got the answer. So this is negative 0.217 r. cm per second. Is it per second? Usually just write in terms of, they did not write, right? So I'm just going to leave it as such. There's no units. So this is, if you can, you just cm per second or whatnot. But this is nothing. Maybe you put units per time. That will be good. Always practice writing your units because it helps. It helps. Okay? Yeah. Any question or comment, please let me know. Keep practicing. Just text me. Get hold of me. Okay.